Welcome back, intrepid explorers of the UNSS Phoenix XES 337. Today's voyage will blow your mind, possibly more than any other cosmic adventure we've embarked on. We're diving deep into a concept that seems out of science fiction, but it's a fundamental theory debated by physicists today: the holographic principle. Imagine this: everything we experience in our 3D universe, planets, stars, even you and me, could be a projection from a two-dimensional surface, much like a hologram. Yes, you heard that right. The entire universe might be a hologram. Today we'll delve into this mind-bending concept, explore the science behind it, and pose the big question: could our universe be an illusion, with reality as we know it encoded on a distant boundary? Get ready for a journey that will stretch your imagination into new dimensions. What is the holographic principle? So, what exactly is the holographic principle? This theory comes from theoretical physics and string theory. It suggests that all the information contained in our 3D universe could be represented on a 2D surface. Like how a hologram encodes a 3D image on a flat surface, the holographic principle suggests that the universe behaves similarly. The idea was first proposed by physicist Gerard 't Hooft in the 1990s and later expanded upon by Leonard Susskind. The principle is rooted in the strange behavior of black holes. When objects fall into a black hole, the information about those objects doesn't seem to disappear. Instead, it gets smeared across the surface of the black hole's event horizon, the boundary beyond which nothing can escape. This led physicists to wonder, if the information of a 3D object can be stored on a 2D surface in a black hole, could the same be valid for the entire universe? Example, think of a DVD that holds a movie. The images you see on your screen are 3D, but come from a flat surface where all the data is encoded. The holographic principle says something similar might be happening with the universe: the connection between black holes and the holographic principle. To understand how this works, we must revisit black holes, those mysterious cosmic objects where gravity is so intense that not even light can escape. In the 1970s, Stephen Hawking made the shocking discovery that black holes aren't entirely black. They emit a faint amount of radiation, now called Hawking radiation. But here's where things get weird. If black holes emit radiation, they can eventually evaporate and disappear. So what happens to all the information about the things that fell into the black hole? This created a paradox known as the black hole information paradox. According to quantum mechanics, data can't be destroyed, but according to classical physics, anything that enters a black hole should be lost forever. Enter the holographic principle. It suggests the information isn't lost, stored on the black hole's event horizon. This principle can be extended beyond black holes to the entire universe. Just as a black hole's event horizon encodes information about everything inside, a 2D boundary could encode all the information in our universe. Interesting fact: some physicists think the universe's holographic screen might be the cosmic horizon, the boundary of the observable universe. Beyond that horizon, we can't see or detect anything, just like we can't see beyond the event horizon of a black hole. The science behind the holographic principle. Now, let's dive into the math and science behind this mind-bending idea. The holographic principle is deeply connected to string theory, which posits that the fundamental building blocks of reality aren't particles but tiny, vibrating strings of energy. One of the critical insights of string theory is that space and time might be emergent phenomena, meaning they arise from more fundamental components. The holographic model gained traction with the development of something called the ADS-CFT correspondence, a theoretical framework proposed by physicist Juan Maldacena. This model describes a relationship between two types of physical systems, one that exists in a higher dimensional bulk space and another that exists on a lower dimensional boundary. In this model, the bulk, our 3D universe, is described by the physics on the boundary, a 2D surface, much like a hologram. This idea is still highly theoretical, but it's one of the most exciting developments in theoretical physics because it might provide a bridge between quantum mechanics and general relativity, two currently incompatible theories. If the holographic principle is true, it could revolutionize our understanding of everything from black holes to the Big Bang, to the nature of space and time. Riddle: I show you depth, but I'm flat to see. I hold the stars, yet weigh nothing to thee. What am I? What would a holographic universe mean for us? If the holographic principle is true, it has some wild implications for how we think about reality. First, it challenges our intuition about the nature of space and time. If everything we experience in 3D is encoded in 2D, then our understanding of physical reality is incomplete. Secondly, it raises profound questions about free will, consciousness, and the nature of existence. If we are just complex patterns of information on a 2D plane, with our 3D world as a kind of projection, does this mean everything we experience is an illusion, like characters in a video game controlled by code? The holographic principle challenges our understanding of reality and existence in ways that are both fascinating and unsettling. The holographic principle also has practical applications. Some scientists believe that understanding the universe as a hologram could help us solve the quantum gravity problem, one of physics' biggest challenges. It could help us unlock the secrets of quantum computing, leading to advances in technology that are currently unimaginable. Example: it's like playing a video game in a virtual reality headset. While you experience a fully immersive 3D world, the game itself is just lines of code running on a flat computer chip. If the universe is a hologram, we might be players in the ultimate cosmic simulation. Did you know that some physicists believe the universe's holographic nature could explain why we don't observe gravity and quantum mechanics working together? The holographic universe may allow a new understanding of gravity as an emergent phenomenon rather than a fundamental force. Now it's your turn to join the cosmic conversation. What do you think about the holographic principle? Could our universe be a 3D projection from a 2D surface? Or is this just a wild theory with no basis in reality? Let us know your thoughts in the comments below, and don't forget to vote in our poll. Do you think the universe is a hologram? Yes, no, or maybe? As we wrap up this mind-bending journey into the holographic principle, prepare for our next adventure into the heart of another cosmic mystery. Are we living in a simulation? We'll explore the idea that our universe might be a hologram and a computer simulation run by an advanced civilization. Could everything we experience be part of a giant cosmic program? Find out next time as we dive into the simulation hypothesis. We hope today's exploration of the holographic principle has expanded your mind to new dimensions. Whether or not the universe is a hologram, these ideas push the boundaries of what we know about reality and remind us just how much there is left to discover. If you enjoyed today's episode, subscribe to Crazy Franks' crazy video productions on YouTube and hit that bell icon. Hence, you never miss out on a new cosmic journey. And if you want even more content, check out Being Frank with Crazy Frank, where we tackle the biggest questions in space, science, and beyond. Answers to riddles. Answer: a hologram. It appears in 3D but is flat. Answer: the event horizon of a black hole. It encodes information on a 2D surface but represents a 3D object. Answer: the universe, if the holographic principle is true.
And thanks for watching.